Okay, so let's look at a second problem. Let x be a continuous random variable with given PDF is given. So first find the expectation of x to the power of n for n equals 1, 2, 3. And then after that, find the variance of x. So, the variance of x is equal to the expectation of x squared minus the expectation, then square. Okay. So as you can see, if we can figure out what is the expectation of x to the power n, and then we can let n equals 2 to drive this pieces, let n equals 1 to get this. So we can easily to figure it out what is the variance. Okay, so starting from the first part, looking for the expectation of x to the power n. So following the definition, using the lotus, we're going to have it's x to the power n f of x dx. That is, x is from 0 to 1, x to the power n times x squared plus 2/3 dx. Okay, so that's it. So we can write it down as distributed, it's x to the power n plus 2 plus 2 over 3 x to the power n dx. Okay. Easily, based on the power rule of the integration, so you have x n plus 3 over n plus 3, right? Plus 2 over 3 times n plus 1, x to the power n plus 1, right? And then evaluate it at from 0 to 1. So we know that when x equals 0, so this part both 0, equals 1, so you derive it, so 1 over n plus 3 plus 2 over 3 times n plus 1. Okay. And yeah, so that's it. Now, when we got this pieces, so the expectation of x squared, which is when n equals 2, so it's 1 over 2 plus 3 plus 2 over 3 times 2 plus 1, which is 1 over 5, right? Plus, this is 3 times 3 give us is 9, so it's 2 over 9. This is 9 plus 10 over 45, so it's 19 over 45, okay? And then e of x, which is 1 over 1 plus 4 over 3 times 1 plus 1, which gives us is, so this is 1 plus 3, okay, my bad. So it's 1 over 4 plus 1 over 3, okay? And then, so give us is 7 over 12, okay, 7 over 12. So, and then after that, all you need to do is just do, so the variance is just a 19 over 45 minus 7 over 12 squared. Okay. I mean, you can leave your answer like that. That's fine. So that's number 2. So I think the major part is to use the lotus, right? That's problem 2. Problem 3 is we let x to be a continuous, again, random variable with a given PDF, which when x is between 0 and 2, so it's a 5 over 32 x to the power 4. And also, we have a function. That function is defined as x squared. So it asks us 3 pieces. First of all, figure out what is a CDF, and then what is a PDF, and then what is the expectation. So noticing that if we can drive the CDF and then we take the derivative, we're going to get the PDF easily. And then y should also easy to doing the integration, right? Because we got the PDF. So noticing that, since x is between 0 and 2, my y equals x squared. So out of y, actually it's from 0 to 4. Okay, so that's something you need to know that. So if we want to do with the CDF, so think about it, if y is less or equal than 0, noticing that the CDF here is going to be equal to 0, okay? And then when y is, let's see, greater or equal than 4, so also notice that this equals 1. So there's no result. So the only part we need to take a look at is okay, when y is between 0 and 4, right? So when y is greater than 0, less than 4, okay? So that CDF, based on the definition, it's y is less or equal than y here. Our y is equal to x squared, right? So x squared less or equal than y. So if we try to solve this, this gives us is x actually is greater or equal than 0, less or equal than square root of y, right? Because if you solve this part, it's going to be x is greater or equal than negative square root of y, less or equal than positive square root of y. But our x is already from 0 to 2, so so we have that it's equal to greater or equal than 0 and less or equal than y. So this is a probability. So it's from 0 to square root of y, and then remember, which is the integration of the PDF. So it's a 5 over 32 x to the power 4 dx, right? So it's easily you can drive these pieces. That will give us is x to the power 5th over 32 from 0 to square root of y. So it turns out we can easily drive this is square root of y to the power 5th over 32, right? Or you can write it down as y squared times square root of y over 32, even to simplify this. So the part 1, the CDF of y is going to be 0 when y is less or equal than 0. When y is greater than 0, less than square root of less than 4. Okay, so it's y squared square root of y over 32. When y is greater or equal than 4, this equals 1. Okay, so that is our CDF. Regarding to the PDF, do you see you just need to take the derivative, right? So f of y, which is the derivative of this piece is, as you can see, it's gonna give you, it's a 5 over 2 times this, so it's 64 y to the power of 3/2. 3/2, okay. And then, so when y is, well, greater or equal than 0, less or equal than 4, and otherwise, it's 0. So you see here, guys, this inequality, it really not make that big difference. Okay, so I mean, you can also put it here is less or equal than 4, and then greater or equal than 0. It won't hurt the result. Okay, it won't hurt about that part. So okay, so when you got that PDF, and then to figure out the e of y, you can do two things. You can either integrate it based on this pieces. So this is part 1, part 2, right? Part 3, figure out e of y. You can do y this, okay, or you can do through the lotus, which is e of y equals e of x squared f of dx. Okay, so if you follow with the x squared part, so remember this is our function, right? From 0 to 2, 5 over 32 x to the power 4. So 0 to 2 x squared times 5 over 32 times x to the power 4 dx. And then, you know, so you can easily to do the calculation, right? So this is 5 over 32 x to the power 6 dx. So it's going to be 5 over 32 x to the power 7 over 7 from 0 to 2. Okay, so of course you can evaluate it. So it's 5 over 32 times 2 to the power 7 over 7. So this is 2 to the power 6. Okay. Well, no, 2 to the power of fifth, I think. Yeah. And then, so if you simplify that pieces, that will give you, it's a 2 square, and then that's 4. So it's a 4 times 5 is 20, so it's a 20 over 7. Okay, so that's how to drive that. Okay, cool. So last one, let's take a look at this one. So x is a normal distribution with a mean is 3. The variance is 9. Okay, and then we have y is equal to 5 minus x. So we want to know that, okay, how do we figure out what is the probability when x is greater than 2, and then what is the probability y is greater than 1, less than 3, and this is a conditional probability, right? Okay, so let's take a look. So when x is part 1, when x following the normal distribution 3, 9, meaning the mu of x is 3, right? So the standard deviation of this one, it's the square root of 9, which is also 3. Okay, so p x is greater than 2, it's equivalent to write here 1 minus p is x is less or equal than 2. Okay, and then we can write this part in terms of the standard normal, which is, as you can see, it's equal to phi of 2 minus the mean, and then over the standard deviation. So as you can see that this is equal to 1 minus phi of negative 1/3, which phi of negative 1/3 equals 1 minus phi of 1/3. So if you substitute, this will give us is phi of 1/3. Okay, so that's the first piece. And of course, we don't require you to figure out, what's the real value of phi of 1/3. Okay, so as long as you drive this in terms of phi, then it's good. Part 2, what is probability that y is greater than 1, less than 3? So since y equals 5 minus x here, keep in mind that the expectation, it is a linear. So in other words, mu of y equals 5 minus mu of x, which is mu of y equals 5 minus mu of x here, which is equals 2. Okay. While the variance, variance of y equals the variance of 5 minus x here. So keep in mind, the variance is not a linear term. So this part is going to be, so the variance of this a x plus b is going to equal to a squared. So this is what I mean. So if y equals ax plus b, and then so the variance of y is the variance of a x plus b, and then equals to a squared variance of x. Okay, so it's not linear thing. So this variance actually is equal to negative 1 variance of square. So this part actually, this is also equals 9. Okay, so correspondingly, standard deviation of y is also square root of 9. It's a 3. Okay, that's something we can tell. So in other words, y follows the normal distribution of 2. 9. Okay, so if we're looking for what is a p of y is greater than negative 1 less than 3, so easily we can do is just use phi was less than 3, so it's a 3 minus 2 over 3 minus, for here it's negative 1 minus 2 over 3. So as you can see, this is equals to phi of third minus phi of negative 1. Okay. Of course, you can write this one as 1 minus this part, so it's phi of third plus phi of 1 minus 1. Okay, that's part 2. Part 3, what is the conditional probability when x is greater than 4 given y is less than 2. Okay, less than 2. So in other words, since this y equals 5 minus x, so you see, we can convert this all in terms of x. So that is given 5 minus x is less than 2. So that is, if you solve this part, it's going to be greater than 4, given that x is greater than 3, right? Okay. So the conditional probability, it's the probability of this, and then over the probability of x is greater than 3. So it's a probability of and over the probability of x is greater than 3. And hence, so this and this do agree is strictly the probability x is greater than 4, right? So it's so let me use new. Okay. So this part is equals probability of x is greater than 4 over the probability of x is greater than 3. And then we know this is 1 minus so we can all handle in terms of the phi, right? Which is phi 4 minus 3 over 3 over 1 minus phi of 3 minus 3 over 3, right? So, so on the top, you're going to have this 1 minus phi of a third. This is 1 minus phi of 0. Okay? Yeah. Phi of 0 equals 1 over 2. So this part becomes into 1 minus 1 over 2 is still 1 over 2 if you do the reflect. So it's 2 times 1 minus phi of 3. Okay, so that's it. That's all about those questions. Okay, thank you for watching.